I'm going to talk about the database indexing. So database indexing, it means you have the lots of data. So how could you, based on different situations, use the good way to fetching the data? So indexing is kind of like we have the if we have the database table, it has some like ID something, and we can based on for the ID it means indexing. It's kind of like when you read the book, and you have page 1, page 2 something. This also means the indexing. It's kind of like it means something to tracking your location about the access for the specific information. So this is the high draft one. How could you design the database indexing? So let's start from here. So you need to make sure whether the need efficient data access, right? You want high performance or low latency or something. So based on this situation, we have yes or no. If no need efficient data access, which means we can accept some latency, so we can directly get the full table and scan it, pick up what you want, right? So if for here, if yes, which means, and also we have to check the table size, whether it's large, so many is larger than the 10K rows. If no, right, which means the table is still small, we still can use the full table, scan it, it will not impact too much latency. If the table is huge, is more than this number, we have to pick up another solution. So what type of data you are querying? If you are use the full text searching, right, we need to use this invert index. And if you are searching for the location, right, we need to use the geospatial index. If you are searching some in memory exact match, so we have to use the hash index. If everything others, we can just use the general one is B tree. So in the B trees, we have multiple columns required together. Yes, we need to consider the composite index. Or heavy read on few columns. Yes, then we consider converting index. So based on your different situations, we choose different thing. So let's start from this first. How to find a row in a database without an index? So the first thing is pull a page into the memory and search for the row. So for current here, original page 1 is in here. Copy here. Yeah. Page 1 original, it's in the database, in the disk. And then when we access, we need to transfer page 1 into the memory here. You can see pull another into the memory and search for the row. And now we got the page 1 in the memory, and now we can based on those informations and to search the row and pick up what we need find. If we find the row, then just return back. So it's kind of like find a row in the database without index. So translate for the page. So another solution which is called like a B tree. So for example, for here, we need to select this is SQL language, select everything from the users where the age is equal to 51. So we need to find, so this one is kind of like a node or page, whatever you want to, you have to identify. So this means the age. So we need to, this is the root, to find the 51. So 51 is between 15 and this one is, it's 90. Between the 90, and which means it's between here. Then it will go to the next level. Oh, it's current here. So we need to find start, okay, this one, no 51. So which means it will return something empty. If we here, 51 should be here. It will search this. And then it will return, oh, current here, we find it 51, just to return back. So nodes optimized to fit in a single disk page. So this is the B-tree index. So what is the hash index? So hash index is current here, right? We have some information here. It's kind of like a input, and based on the hash function, then we will hash this input. It will get specific key and point it to the key and to check the value also stored in here. So this is the hash index. You can see here, like hash this and go to this one and go to the, okay, so this value about this one is the page 3 and then return back. So this is hash index. So what is the
Geospatial.
Geospatial. Geospatial means based on the location, like long is length. Select location larger than this one and this one, and right, so we can focus on the specific location to find it or where the location. It's very often used in Uber. Some based on the map, some based on the location part. So we have during the geospatial index, we also have 3 different ways to do the location part. The first one is called geohashing. You can see we separate by this one is location here and separate by the single one, and then we still, if we just large it, zoom this, we can see we also can separate location in more detail until we find the specific one. So layer 1, layer 2, layer 3. So you can design it how much you want. So this is called geohashing. See here, you can see here, right? So to more detail, and you can find the specific location. It has some like advantage. Simple represent as a single string, make it easy to store and share efficiency for proximity search, as nearby location often share a prefix. Uniform distributed hash values, and also has some like disadvantage. Precise vary across the latitudes. Higher latitudes have less precision, not as efficient for bounding box searching due to its z-order curve property. Boundary issues, right? Adjust array may not share the same prefix. It's a specific. This one is also pretty tricky to check. If we just enough here, so how could you design this? So this is kind of like another problem, but we will not go in detail. But this is kind of like idea about the geohashing. So what is the quantum tree? It's like here. Quantum tree is this one is store the whole table, right? And for here it's like it's used the tree data structure to store this thing. And if we find it, we just it's more like, I would say it's more like try. You can see here, this is current here, and you just need to search in this one based on the tree is improve the efficiency. Right, this which means how many layers you want to go inside. And what is the retree? Retree is more dynamic. It's not like structural here. And based on you can see here, you can go to different way. It's more dynamic. It's not all the areas got the same space. So based on some it's good in some like New York. It's so many people. So when Uber want to deliver something, they will use the dynamic way for some like a hotkey, some hot location. Use this way is good. So this is the R tree here. So what is invert index? Invert that we can treat this one, select something, post where contains like some database, right? Something like here, maybe we can use like fast or happy, whatever. Then we have the documents, right? For here, handle requires where. So we it will say you create another index table, and when we search this keyword, it will directly go, oh, this something is in the document 1, you just directly search the document 3. It's kind of like use the second layer table to do this. Yeah, this is the, okay, everything finished? Sorry. Oh, so this is the last one, invert index. Yeah, let's look back just from the high level ideas come up again. So based on different scenario, we have to make sure the problem first is whether we need efficient data access, whether we need very low latency, right? Low latency. If no, we just gather the full table and scan it, it's fine. And for here, if yes, but also we need to, based on if the table size is very small, we also can use the very simple way, like gather the whole table data and read it directly. If the table, the database is too large, we need to use the inverse index, geospatial index. Sorry, let me try again. Geospatial index or hash index B-tree to improve the performance. So this based on if we want to for text search, we use the invert index. If we want to local data, we can use the geospatial index to check in the local part. And for the memory, like hashing something, we can improve the performance, especially for the Redis database. And the other normal is general one is use the B-tree. Yeah, thank you.